This is a lesson for the notes on law of conservation of mass. So the document that you should have open looks like this. It says notes, chemical equations, and the law of conservation of mass. There are 2 links available, the slideshow that we're about to go through, as well as this video that you're watching right now that I'm filming for you. All right, let's get started. So a chemical equation shows a chemical reaction taking place. So let's use photosynthesis as an example. When we see that big, long photosynthesis equation, what it's really showing us is what's happening during photosynthesis, the actual reaction itself. So a chemical equation shows a chemical reaction taking place. The equation shows the substances involved before and after the reaction takes place. So you see the reactants, the before stuff, the ingredients, if you will, and the new products, the new substances that are created because of the chemical reaction. So you are labeling this diagram here. So the Mg is the chemical symbol, in this case for magnesium. Remember, chemical symbols are 1 or 2 letter abbreviations. The first letter is always capitalized. That little 2 there is a subscript. And what a subscript tells us is how many atoms we have of a particular element. So since this oxygen has a subscript of 2, it tells me I have 2 oxygen. The yields sign, or this arrow here, is kind of like the science equivalent of an equal sign. What it's actually showing, that yields means to create or to make. So this molecule plus this molecule will create or make this new substance over here. Coefficients are always the big numbers in front of a chemical formula, and that tells us how many molecules of that particular compound we have or how many copies. So this is magnesium oxide, and I have 2 molecules of magnesium oxide. And then, of course, that's a chemical formula. A chemical symbol is a 1 or 2 letter representation of an element. A subscript tells us how many of a certain element we have in a substance. The yield arrow means to create new substances. It's like the equal sign. And a coefficient tells us how many molecules or copies of a substance are in a reaction. So if you ever need to pause the video because I go too fast, then pause the video when needed and press play when you are ready to hear me talk again. You have to press play eventually, though. Don't leave me hanging out there. So in this particular example here, Na2SO4, it's 2 sodium atoms, 1 sulfur atom, and 4 oxygen atoms. In the other picture, the one with CO2, 1 carbon, 2 oxygen, and I can kind of see that visually represented with my yellow, my red and blue little circles there. 1 carbon, 2 oxygen. And if I have 2 CO2, it means I have a coefficient of 2 in the front. That's telling me I have 2 copies, 2 molecules of carbon dioxide. And I can see, again, in my diagram that I have like 2 pair. So this is a visual representation of what reactants and products mean. Reactants are your starting ingredients, so it's the chemical compounds or molecules that you start with. Then they react, that's the yield sign, and then they create new substances. Those are your products. So here I can see I have 2 magnesium reacting to an oxygen molecule to create 2 magnesium oxide molecules. Reactants are the substances before the reaction, the ingredients. Products are the new substances created in the reaction. The reactant should always equal the products. And that's where the law of conservation of mass comes in, the idea that matter or mass cannot be created or destroyed. So if I start out with 1 carbon and 4 hydrogen and 4 oxygen, which is what I have here, I can see it visually, then even though a chemical reaction is going to take place and I'm going to make new substances, I still should have 1 carbon, 4 hydrogen, 2 times 2 is 4, 4 hydrogen, and 4 oxygen 2 of them are there, the other 2 are here. As long as this side always equals what's on this side, then it is a balanced equation that is observing the law of conservation of mass. What is the chemical equation for photosynthesis? Who remembers the chemical equation for photosynthesis? If you don't, there it is. 6 carbon dioxide molecules react to 6 molecules of water. Sun helps to facilitate this reaction. It is the catalyst that makes this reaction take place. You yield a molecule of sugar and 6 oxygen molecules. Whatever was on this side of my equation must be on this side. So if I have 12 hydrogen, 6 times 2 is 12 hydrogen, those are my 12 hydrogen over here. Identify the products in the chemical reaction below. Okay, well, my products are labeled for me. My products are glucose and oxygen. This chemical formula and this chemical formula. How many atoms of oxygen are on the product side? So if I'm looking just at the product side, that would be the new substances. 6 times 2 is 12 oxygen, but I also have 6 oxygen over here. So 12 plus 6 is 18 oxygen. How many atoms of hydrogen are on the reactant side? So I'm just looking at hydrogen, and it's right here. 6 times 2 is 12. But if I look over here, I also have 12, which is how it should be because they should be the same on both sides of my chemical equation. I'm going to skip the video. You guys can watch that. You know that videos and me do not work. We just can't figure out a good way to coexist. So you can play that later for yourself. Let's keep going in the notes. The law of conservation of mass says mass or matter or energy, all those words can be interchanged because it's all the same. Mass, matter cannot be created or destroyed. It can only change or transform into a different, either a new substance or into a new light energy, sound energy, but it exists in the universe somewhere. It doesn't just go away. The reactants must equal the products. So whatever, however many carbon or hydrogen or oxygen I start out with, I must have the exact same amount when I make these new products. They may have paired up differently into new substances, but they're all accounted for. They're all there. So when I look at the chemical composition of wood and then burning that with oxygen, so the mass of wood and oxygen is going to be the same, even though you yield ashes, carbon dioxide gas, and water vapor, 3 new substances. All of the atoms that were involved in this side must be present on the other side. We need to recognize if a chemical equation is observing the law of conservation of mass. So how I know if a chemical equation is following the law of conservation of mass is I have to figure out, are the atoms the same on the reactant side as they are on the product side? I have to count all the atoms up. And what I'm looking for is this representing a balanced chemical equation where both sides are balanced? The same amount of atoms of elements are here as they are over here. The reactants equal the products. Or is there something wrong and they don't match up? We call that an unbalanced chemical equation. So how I count my atoms, I have to literally create a chart. So I create a chart that represents what elements and how many of those elements, how many atoms of those elements are on my reactant side. I represent that a chemical equation is going to take place with my yields symbol, and then I have to tally up what's on my product side. So if I look at this example, in that balanced chemical equation, CH4 plus 2O2 yields CO2 plus 2H2O. Basically, that's a methane atom reacts with 2 oxygen atoms to create a carbon dioxide molecule plus 2 water molecules. That's how I would say that chemical reaction. I have 1 carbon. There it is right there. I have 4 hydrogen. And I have 4 oxygen. That's my reactant side. Those are my starting ingredients. I have to see that that matches on the other side. And I have 1 carbon. I have 2 oxygen right here, but I also have 2 oxygen over here because remember you take the coefficient, the big 2, and I have to multiply it times this and this 1 oxygen. So 2 plus 2, and then 2 times 2 is 4. So I end up with all the same things. It all is balanced. My other example, my unbalanced chemical equation. So my methane molecule reacts to my oxygen molecule to yield a carbon dioxide and a water molecule. It looks very similar to the other one, except that now if I look at my reactants, I have 1 carbon, 4 hydrogen, 2 oxygen. And then if I go over to my products though, I have 1 carbon, starting out pretty good. I've got 2 hydrogen, and I've got these 2 oxygen plus that one. So I've got 3. And that doesn't match up. This is not a balanced equation. This is not following the law of conservation of mass. The mass in this chemical reaction must stay the same. The products are the same number of atoms of each element, the same physical mass even. So just before we started these notes, I did the experiment with you where I had the scale and the flask, the vinegar, the baking soda, and the balloon. And it had a mass of 145 grams. And then I mixed the vinegar and the baking soda, trapped the gas in the balloon, created new products, carbon dioxide gas and water being 2 of them, but yet the mass stayed the same. Even though I mixed them up and made new stuff, it was still 145 grams of mass because all of the carbons and hydrogens and oxygens that were involved were still there. The reactants are transformed into new substances, but they are still all accounted for. The law of conservation of mass is being observed. Nothing was created or destroyed. Okay, so for this part, what I would do is I would get some scratch paper and something to write with so that you can practice. And I will do the first one with you. And then I'll give you some wait time so that you can work out the questions 6, 7, and 8, and then I'll put the answers on the screen. So you'll need to do a little bit of pausing, or if you're playing the slideshow, there's a timer down here that you could use. But for the video, I'll pause just for a few moments. You pause, and then press play when you're ready to check your work. So we'll do the first one together. So I can see that I have this chemical equation. NO2 plus H2O yields HNO3 plus NO, okay? I need to make a chart so that I can count my atoms. So I'm going to set it up like this. I've got my reactants on one side, my products on the other. I'm going to list my elements. It should be the same list on both sides. If you have a different list on your reactant side than your product side, then you already know it's not balanced because that's not going to happen. But then I'm going to count them, right? So 1 nitrogen. I see 2 oxygen here, but I need to add it to this oxygen. So everything on this side of the arrow, I always have to combine if they're the same. So 2 oxygen plus 1 oxygen gives me 3 oxygen, and then these 2 hydrogen. So that's this side of the chart. 1 nitrogen, 3 oxygen, 2 hydrogen. Okay, now I go to the other side, the product side. I have 1 hydrogen, 2 nitrogen, because I have to add these 2 together because they're on the same side. These 3 oxygen plus that one is 4. So 2, 4, and 1 does not match. This is not balanced. So this would be a good time to pause the video, make charts for questions 6, 7, and 8, count your atoms, make sure you're getting all of the combined, like if there's an oxygen here, you got to add it to that oxygen, and check your work. So pause. And then when you're ready, unpause. All right, so let's check our answers. So for question 6, you should have 8 carbon, 8 oxygen, and 34 hydrogen. For our product side, you should have 8 carbon, 8 oxygen, and 34 hydrogen. That's a lot of hydrogen. Here I can see it pretty easy because 17 times 2 is 34. But here I have 18, and then I have another 16. I have to add those together. But that's balanced. Okay, for number 7, I see 4 iron, 4 sulfur, 14 oxygen on this side of the equation, the reactant side. On the product side, I see 4 iron, 4 sulfur, 14 oxygen. So that's balanced. And then our last one, I see 2 carbon, 2 hydrogen, 2 oxygen. And then on my product side, 1 carbon, 3 oxygen, and 2 hydrogen. So that's not balanced. Again, let's continue that scrap paper practice. You guys will pause and then check your work, okay? So let's start with an easy set. How many atoms are in this molecule of water? I visually can see it. 3. How many elements are in this molecule of water? 2, hydrogen and oxygen. Here's my favorite. How many molecules are present? Remember, molecules are like copies. So we're looking for coefficients, right? So we'll do the first one together. How many molecules are there of 2AlBr3? Well, it's got a coefficient of 2, and that's my answer. If it has a coefficient, that's how many molecules it has. So pause, do the rest of them, and then check your work. Okay, let's check your work. Remember, if it does not have a coefficient, then it's just one molecule. All right, let's keep going. Are these equations balanced? So same thing, set up your chart, reactant side, product side, list out your elements, and then count your atoms of each element. I'll give you time to do that. Let's check your work. So for the first one, you should have 2 carbon, 2 hydrogen on the reactant side, 2 carbon, 8 hydrogen on the product side, because 2 times this 1 carbon is 2 carbon, 2 times these 4 hydrogen is 8 hydrogen, so not balanced. Number 2, 4 hydrogen, 8 carbon, 4 hydrogen, 8 carbon. This one's balanced. So on this side, my 2 times 2 is my 4 hydrogen. My 2 times this 1 oxygen, so there's 2 here, and then 6 here, and 2 plus 6 is 8. How many atoms are there in the following? And notice it's asking specifically for one of the elements. So we'll do the first one together. How many atoms of hydrogen are in this chemical formula? Well, hydrogen all by itself looks like it's 3. But it's inside parentheses. So I know this little subscript of 2 is going to have to get multiplied by everything in the parentheses. So if I did that, it would be really 4 oxygen, really 6 hydrogen, and that's our answer. Go ahead and pause, work on these, and then unpause when you're ready to check your work. All right, let's look at the answers. So again, when you have parentheses, and all of these do, I know it's tricky. I do have a video tutorial in the week 7 folder of just how to work with parentheses if you need to watch that again. But we're looking for only hydrogen in this one. So again, only oxygen. O is for oxygen. Only oxygen in this one. So the oxygen inside the parentheses tells me I have O4. I have 4 oxygen. But I have to multiply it by the subscript outside the parentheses, and 4 times 2 is 8 oxygen. Here I'm looking for only the hydrogen. Inside the parentheses, I have 4 hydrogen, but I must multiply it by the subscript of 2, and 4 times 2 is 8 hydrogen. Only arsenic. Arsenic, AS, is not in the parentheses. So I can ignore the S, the O4, and the little subscript 3. That has nothing to do with my arsenic because arsenic is not in the parentheses. So I just have 2. How many carbon? Carbon is in the parentheses. There's 1 carbon in the parentheses that gets multiplied by this 2. So 1 times 2 is 2. Okay, that is the end of our notes. That's it. We done. If you do have any questions, know that your teachers are here to help you. Please come to our tutorials.